Yes, sir. Put the heading optical isomerism. Is it audible, right? Optical isomerism. Nana. So generally normal light. So actually what is optical isomerism? In this optical isomerism, we are going to do a lot of things here. One is first normal light, then plane polarized light. So then we will see its optical activity either clockwise or anti-clockwise, and which type of compounds will exhibit the optical isomerism, what is plane of symmetry, what is center of symmetry, and what is axis of symmetry, and counting of optical isomers in case of symmetrical and unsymmetrical, what is meso compound, what is enantiomeric pairs, what is diastereomeric pairs. So all these things we will discuss in this particular optical isomerism, somewhat important. So total in isomerism, structural isomerism, stereoisomerism. In structural isomerism, we discuss chain, position, functional, metamerism, and tautomerism, and ring chain isomerism. And in case of stereoisomerism, conformational isomerism, configurational isomerism. In conformational isomerism, in last class we discussed, right? That is Gaussian, eclipsed, partial eclipsed, staggered, right? So then stabilities in hydrogen bonding and Gaussian effect. We discussed those things. And today we'll discuss this in configurational isomerism, geometrical isomerism we completed. Now the last thing is optical isomerism. Okay, normally in optical light, normal light, for example, electric field and magnetic field is there, right? Electric field, one is magnetic field. So both are perpendicular, right? In this perpendicular, propagation of light perpendicular to these two. The propagation of light, right? Electric field, magnetic field, propagation of light. So normally try to understand. So for normal light is having in all directions, right? For example, if you can say, if you take the normal light, in which directions? In infinite directions it's moving, yes or no? In different directions it's moving now. It's in different directions it's moving. So this normal light, when we are passing to a polarizer, when we are passing the polarizer, what exactly happens? So all lights are in the one plane, that is called vector sum. All light that we are called as plane polarized, right? Write it down. Plane polarized light. So when diffraction, polarizer, and the normal light in all directions, when we are passing through the diffractor, so polarization takes place all vector sum. Like see, for example, normal light is normal tube light in all directions, yes or no? For example, did you see that radium light? It's going in only one plane, straight like that. Now, whatever the compound, if we want to check, right? Whatever the compound, if we would like to check whether the compound is SI meter tube length, this is polarimeter tube, concentration in gram per ml we will take, concentration gram per ml, the length of the tube, polarimeter tube. In the polarimeter tube, whatever the organic compound, we want to check optical activity, whether that compound is optically active or not. So we are passing the optical, right, plane polarized light like this. When the light is passing this solution, right, in this case, so here is the light rotates clockwise direction or anti-clockwise or either going straight now. If it is right clockwise direction, so sometimes, for example, try to understand, this is it's not moving in the polarimeter tube, right? So for example, actually this one, it's moving right side direction, like this, right side. So clockwise direction. Clockwise means what? We could say small d or dextro. If it is left side, if it is moving, actually this is like this. The light is moving the left side direction. Small L, LEVO. So if it is going straight, means that is racemic mixture. Racemic mixture, right? So total normal light, right? Normal light when we are passing through the polarizer, so we'll get plane polarized light. This plane polarized light we are passing through the polarimeter tube. If this plane polarized light is rotates clockwise direction or anti-clockwise direction, or it can go straight line. So it is plus, this we could say minus. So this is plus and minus now. Racemic mixture means straight line. Simply, the compound is optically active means it rotates the plane polarized light either clockwise direction or anti-clockwise direction, doesn't matter. So just note it down this. This is just basic thing. The vectors are one direction. Length will take in decimeters. So here is for example, this is the meter now. The arrow is like this. If it is clockwise direction means this is moving right side. Okay now? Hello. So like this, the yellow color one. This is theta is coming. If it is coming back side, means left side. So left side. This is theta. Theta means left side, observed angle of rotation. This is plus or small d, or we can say dextro. This is plus or minus racemic mixture. This is L or minus LEVO. So ఏంటంటే when we are passing to the plane polarized light, if it is rotates either clockwise direction or anti-clockwise direction. Clockwise direction means this is moving right side direction. So theta, angle of. Otherwise, if it's not moving any direction, it's straight only. That is nothing but racemic mixture. If it is moving right, left side, clockwise or anti-clockwise or going straight. LEVO rotator. LEVO rotatory or minus. So simple normal light exposes all directions. So actually optical activity we are just discussing experimentally. So the compound is optically active. Active means what? Simply we are passing the plane polarized light. So when we are passing the plane polarized light, if it is rotates clockwise or anti-clockwise. If it is clockwise, we could say dextro-rotatory. If it is anti-clockwise direction, LEVO-rotatory. Dextro-rotatory means positive charge, plus or small d. We are having capital D also, that is different case. I'll explain that. So we have to write the small d and small l. Small l means LEVO-rotatory. LEVO-rotatory means what? When we are passing the plane polarized light, optical active compounds means either clockwise or anti-clockwise, doesn't matter. Right? If it is going straight, means racemic mixture. Racemic mixture means what? Optically active. Inactive. Optically active means either clockwise or anti-clockwise, optically active. If it is going straight means optically inactive. Optically, racemic mixture means optically inactive. So practically we will say like this. So here is theta is one, theta we can observe here is, right? What is that theta? For example, if it is rotates like this, Nana, clockwise direction, here is the theta is coming. This theta we are called as observed angle of rotation, write it down. Observed angle of rotation. Observed angle of rotation. This theta is directly proportional to, right, length of the tube, Nana. Length of the tube, and theta is directly proportional to concentration. Concentration which we are taking in the polarimeter tube. The polarimeter, the length is there, the length we are taking in decimeters, and the concentration we are taking gram per ml. Gram per ml. Theta is the observed angle of rotation is directly proportional to length of the tube and concentration of the solution. Write it down. If more concentration, more angle. So polarimeter tube length is more angle. Write it down now. This theta is nothing but, what is this theta? Observed angle of rotation. This observed angle of rotation is directly proportional to length of the polarimeter tube and concentration. If we are taking the more concentration, more angle we can observe. So directly theta is directly we can say P into L, right? Directly proportional. If your theta is equals to alpha T by lambda T into L. This is we are called a specific angle of rotation. Alpha means what? What alpha? Specific angle of rotation. Specific angle of rotation. T means absolute temperature, lambda means monochromatic wavelength of light. So we can write alpha is equals to T lambda is equals to, right, theta by T into L. Temperature. Wavelength, monochromatic like wavelength. This is monochromatic light wavelength. What is theta? Observed angle of rotation. T means what? Concentration. Concentration we have to take in gram per ml. This is length of the polarimeter tube. We have to take in decimeter. Write it down. So based on that, some numericals they'll ask. Concentration of solution, whatever we are checking the optical activity. Any optic, for example, some X compound they are giving us. So any compound. Let me know which is the optically active or not. How should we do? Simply we have to put in that one. We have to pass the plane-polarized light. If it is rotates clockwise or anti-clockwise, that is optically active. If it is going straight means optically inactive. So based on this formula, sometimes calculate the specific angle of rotation. The specific angle of rotation is for pure molecules, it's a constant. Observed angle of rotation is purely depends on concentration as well as length. So once again I'm just telling, theta means observed angle of rotation directly proportional to concentration and length. So theta is equals to alpha pressure C into L, the specific angle of rotation. T lambda is equals to theta by T into L. So for example, the specific angle of rotation is produced. For example, the concentration we are taking 1 gram per ml. If the concentration we are taking 1 gram per ml and the length of the tube also we are taking 1 decimeter. If concentration we are taking 1 gram per ml and the length is 1 decimeter, then what exactly happens? What exactly happens now? Hello? Alpha is equals to theta. Observed angle of specific angle of rotation is equals to observed angle of rotation when, if you are taking the concentration is 1 gram per ml and length of the tube is equals to 1 decimeter. Write it down this. So write it down. Specific angle of rotation produced by when concentration of substance is 1 gram per ml, when concentration of substance is 1 gram per ml, when concentration of substance is 1 gram per ml, and length of the polarimeter tube, 1 decimeter. 1 decimeter. So specific angle of rotation is produced by when concentration of the substance is 1 gram per ml and concentration of the substance 1 gram per ml and length of the decimeter, right, polarimeter tube is 1 decimeter. Length of the polarimeter tube is 1 decimeter, then alpha will produce. Alpha is what? Specific angle of rotation, right? For pure molecules, alpha is constant. Write it down. For pure molecules, alpha is constant. For pure molecules, alpha is, for any pure substance, alpha is a property of molecule which remains constant. Alpha is a property of molecule which remains constant. Alpha is a property of molecule which remains constant. Property of a molecule which remains constant. Particularly here, which type of compounds, each and every time we can't do the experiment in the examination hall, in the classroom. It is not possible, yes or no? For example, some X compound, ethyl alcohol which I am giving you, whether the compound is optically active or not. How should we say? For example, glycine. Glycine is a molecule which I am giving like this. CH3. For example, I will take CHNH2. OH. This is alanine. Alanine is an amino acid. It's an amino acid. Whether this amino acid is optically active or not. Any compound. If any compound optically active or not means we can't do the experiment in each and every time. So for that purpose, what we need to do, we need to know 3 important things. The first important point, compound should have at least 1 chiral center. What? Chiral center. Compound, any compound should have at least 1 chiral center. What is chiral center? Carbon is having how many bonds, Nana? 4 bonds, right? A, B, C, D. So the carbon, if contains 4 different groups. The carbon contains 4 different groups or atoms, whatever it may be, right? So that is chiral center. So for example, we'll cross check. So compound should have the 1 chiral center and they should not possess any symmetry. Plane of symmetry, center of symmetry, axis of symmetry. So they should not possess any symmetry. We'll discuss these 2, very important. First point and second point. So first we'll discuss about chiral center. Okay. So first put the heading chiral center. Chiral center. Chiral means what? For example, CH3, CH2, CH3. Is this molecule is having any chiral center? For example, CH4 is having any chiral center? 4 hydrogens are same, right? Not a chiral center. For example, we take ethane. Ethane is having any chiral center? This carbon, 3 hydrogens are same, right? 1 carbon is different. That is also same. It's not possible. In this case, this is 3 hydrogens are same, 2 hydrogens are same, 3 hydrogens are same. No. For example, in this case, CH3, CH, CH3, CH2, CH3. Is it having any chiral center? For example, this carbon, but these two methyl groups are same. 2 methyl, 1 ethyl, 1 hydrogen. Doesn't have any chiral centers. Okay. For example, CH3, hydrogen, CH2, CH3, CH2, CH2, CH3. Does this contain how many chiral centers? Hello. This is called one chiral center. Why one chiral center? Methyl group, ethyl, propyl, hydrogen. 4 different groups. One chiral center. This is one chiral center. So these molecules, methane, ethane, propane, these molecules won't show any optical activity. So, but it can show the optical activity. But then afterwards, after watching the chiral center, you need to cross-check the symmetry. Of course, I'll discuss symmetry, but first, at least we need to identify chiral center. Okay, write it down. Got it? What is chiral center? Hello? Hello? So this is chiral center, right? 4 different groups. Write it down. Carbon, at least it should have 4 different groups or atoms should attach. Sometimes they'll give the big compound and let me know how many chiral centers they'll ask. So let me know how many chiral centers are present in the different molecules. So they'll ask different types of questions. Sometimes if they are giving the line representation, we need to cross check now. So let me know how many chiral centers are possible. So we'll go small compounds to big compounds. At a time, if I'm giving you the big questions, it will become easy questions only. So let me know. Just write it down. First, take ample time. Just write clearly. Right or wrong doesn't matter. One chiral center. Which one? This one. This one is a chiral center. Is this chiral center? 2 methyl groups are A. Okay? Only one. In this case, Nana, this is one chiral center. This also one chiral center. 2 chiral center. In this case, this is one chiral center. This is one chiral center. Any doubt? I think 3 hydrogens same unnai kabatti first one kaadu. Okay na? Second carbon. ఇక్కడ కార్బన్ కి ఏంటి, ఈ కార్బన్ కి మిథైల్ గ్రూప్, ఇదంతా సేమ్ గ్రూపే కదా. హలో, ఈ రెండు సేమ్ వచ్చాయా? ఈ రెండు డిఫరెంట్గా ఉన్నాయి, బట్ 4 డిఫరెంట్గా ఉంటేనే కైరల్ సెంటర్. కాబట్టి ఇది కూడా కాదు, ఇది కూడా కాదు. ఆల్రెడీ 3 హైడ్రోజన్స్ ఉన్నాయి. ఇది కాదు. ఇక్కడ 2 హైడ్రోజన్స్ సేమ్ ఉన్నాయి, 3 హైడ్రోజన్స్ సేమ్ ఉన్నాయి. ఇక్కడ దీనికి ఈ కార్బన్కి ఎన్ని ఉన్నాయిరా? ఒక హైడ్రోజన్ ఉంది. ఓకే, ఇథైల్ గ్రూప్ ఉంది, మిథైల్ ఉంది. ఇదంతా పెద్ద గ్రూప్, ఇదంతా టెర్షియరీ ఐసోప్రోపైల్ గ్రూప్. అంటే ఈ కార్బన్ ఒకటికి ఎన్ని ఉన్నాయి? 3-4 డిఫరెంట్ గ్రూప్స్ ఉన్నాయి. కార్బన్కి ఇది ఒక టైపు, ఇదొక టైపు, ఇదొక టైపు, ఇదొకటి 4 ఉన్నాయా డిఫరెంట్గా? అందుకోసమని ఒకటే కైరల్ సెంటర్ ఉందని చెప్పాను. అర్థమైందా? ఈ కేసులో ఈ సెకండ్ ఈ కార్బన్ ఉందా, దీనికి ఏమేమి ఉన్నాయి చెప్పు. ఇథైలు హెచ్, ఇథైలు, ఇది మొత్తం. ఓకే, 4 డిఫరెన్స్ ఉన్నాయా దీనికి? ఇది ఒకటి. ఇప్పుడు ఈ కార్బన్ కూడా చూడు, ఇదంతా ఒకటి, హైడ్రోజన్ మిథైల్ ఇది 2. ఇక్కడికి వచ్చేసరికి ఇథైలా, ఇది మిథైలా, ఇది ఇంకో పెద్ద గ్రూపు, ఇక్కడ ఒక హైడ్రోజన్ ఉంటుంది. 4 ఉన్నాయా లేదా ఎల్లో కార్బన్కి? ఇప్పుడు దీనికి మిథైల్, ఇథైల్, ఇది మొత్తం 4, 2 కైరల్ సెంటర్స్. ఇప్పుడు చెప్పండి దానికి. So if you are confusing in this particular way, you can write the carbon chains. Right? Write it down. So chiral center. Yes or no? Ethyl, methyl, ఇది టోటల్ ఇదంతా ఇలా తీసుకోవాలి. 1, 2, this total is 3. అండ్ ఒక హైడ్రోజన్. బై డిఫాల్ట్ కార్బన్కి 4 బాండ్స్ ఉంటాయి. ఓన్లీ 3 ఉన్నాయనుకో, రిమైనింగ్ థింగ్స్ వీ నీడ్ టు పుట్ హైడ్రోజన్స్. అర్థమైందా? 1 దిస్, ఇక్కడ ఏమైంది మిథైల్, అండ్ దిస్ టోటల్ ఇంద్ర వాట్ సెకండరీ బ్యూటైల్, ఇది టోటల్, ఇది 3. ఇప్పుడు మనకు 3 కనిపిస్తున్నాయి డిఫరెంట్గా. ఇంకోటి ఏముంది హైడ్రోజన్. అంటే ఎన్ని ఉన్నాయి? ఇది కైరల్ సెంటర్ కాదా? సెకండ్ వన్, సెకండ్ వన్ కైరల్ సెంటర్. థర్డ్ వన్, దిస్ వన్ కైరల్ సెంటర్ ఆర్ నాట్? దిస్ వన్ మిథైల్. ఇప్పుడు ఇది సేమా డిఫరెంటా? ఈ టోటల్ మాలిక్యూల్ రా, ఇది అండ్ ఇది, both are same or different? డిఫరెంట్ అంటే ఏంటి? ఇది కైరల్ సెంటర్ కాదా? ఇప్పుడు ఎన్ని కైరల్ సెంటర్స్ అయినాయి? 3 అయినాయి. ఇది ఈజ్ దిస్ కైరల్ సెంటర్ ఆర్ నాట్? ఫోర్త్ వన్ is methyl, ethyl, this total group. 1, 2, 3 और एक वाला 4, right? Is the chiral center or not? 4. ఇది లాస్ట్ వన్. ఇది కాదు, ఎందుకు? ఇది మిథైల్, ఇది కూడా మిథైల్. సూపర్. ఎన్ని కైరల్ సెంటర్స్ ఉన్నాయి దీంట్లో? 4 ఉన్నాయి. ఇప్పుడు ఇది ఉందిరా, ఇది ఏమైంది? మిథైల్స్ ఏమైందా? కాదు, ఇక్కడ 2 బాండ్స్ ఉన్నాయి, ఇటు ఓకే, కానీ ఇక్కడ 2 హైడ్రోజన్స్ ఉంటాయి కదా? కాదు, ఇక్కడ దీనికి ఆల్రెడీ 2 బాండ్స్ ఉన్నాయి, ఇంకో 2 హైడ్రోజన్స్ పెట్టేస్తాం కదా. ఏబీ నై, యాపై మిథైల్ మళ్ళా సేమ్ వచ్చింది, రైట్? 0. ఇట్ వోంట్ షో ఆప్టికల్ యాక్టివిటీ. Okay, put your hand. How many chiral centers are present in the molecule? ఇది 1, 2, 3, 6. Here, no? This is 1, 3, 4, 5, 7, 9, 10, 10. థర్డ్ వన్ కాదు అని చెప్పి ఎందుకు కాదు అంటే ఇది ఇథైల్ ఇది ఇథైల్ సేమ్ ఉన్నాయి, సేమ్ ఉంటే కాదు. సెవెంత్ వన్ అవుతుంది, ఎందుకు అవుతుంది అంటే ఇది మిథైల్ ఒకటి అండ్ ఇదంతా ఒకటి టోటల్ పేరు, ఇది ఒకటి ఇది 2 కదా, ఇదంతా ఇంకోటి 3 రైట్. ఒక హైడ్రోజన్ ఉంటుంది 4. నైన్త్ వన్ కూడా కాదు, ఎందుకు కాదంటే ఇది ఇథైలే ఇది కూడా ఇథైలే కాదు. మిగతా వాటిల్లో ఇక్కడ ఇప్పుడు ఫర్ ఎగ్జాంపుల్ 4th వన్ ఉంది, ఎందుకు కాదు? 4th వన్కి 2 బాండ్సే ఉన్నాయి, అంటే మిగతా 2 ఏముంటాయి? హైడ్రోజన్స్ ఉంటాయి. 5th వన్కి 2 బాండ్స్ ఉన్నాయి కాబట్టి 2 హైడ్రోజన్స్ రాస్తాం. ఇక్కడ కూడా 2 హైడ్రోజన్స్. 2 హైడ్రోజన్స్ వచ్చినాయంటే 4 లేనట్టే కదా. సెకండ్ వన్ ఓన్లీ 1 రా. సమ్ పీపుల్ టోల్డ్ మీ ద ఆన్సర్ 1. ఈజ్ దిస్ Is this? Is this? Is this? Okay.